Hey everyone, in today's notes from Unit 1, we'll be taking a look at how to partition a segment. Now many of you are familiar with finding the midpoint of a segment, but in addition to midpoint, we're going to work on dividing segments into different ratios. Alright, but starting with midpoint, if we take a look at the line segment in number 1, we notice that it is 4 units long. So if we want to find the midpoint, we just need to cut that distance in half. And the midpoint would be at -3, +2. I want you to check out something for me. Check out those two endpoints, -1, +2, and -5, +2. And notice that while the y value doesn't change, since it's a horizontal line, the x values change by 2. So if we take -5 and add 2, we get -3. -3 plus 2 gives us -1. So notice that the midpoint has the same distance from each endpoint of the line segment. In number 2, we have a vertical line segment, and it's a total of 1, 2, 3, 4, 5 units long. So in this case, we have to cut that distance in half. We want to go 1, 2.5 units to find that midpoint. Right. That midpoint is going to have coordinates of 2, 1.5. Now check it out as it compares to the two endpoints. This one up here is 2, 4, and this point down here is 2, -1. But again, we're still taking a look at a point that's the same distance from the two endpoints. Now, another way to think about midpoint is to think about it as the average of your two endpoints. But just notice the y values in this case, 4 and -1. If we take and we add 4 and -1 together and then divide it by 2, okay, for half that distance, 4 plus a -1 is 3. 3 divided by 2 is 1.5. And notice that's our y value. And number 3, let's check it out. This endpoint is at -7, -3. And this endpoint is at -1, -1. So if we take this idea from the last question about finding the midpoint by finding the average of our two endpoints, take -7 plus -1 and divide it by 2. Then take -3 plus -1 and divide it by 2. That's going to give us -8 over 2 and -4 over 2, which will result in our midpoint right here with coordinates -4, -2. And you can see that we can get that by counting as well. All right, and the fourth one, check out those two endpoints, -2, 2, and 4, -1. And if you notice, if we were going to do this by counting, we go down 3, and to the right 1, 2, 3, 4, 5, 6. Well, half of 3 would be 1.5 right here. Half of 6 would be 3 right here. And notice where they meet is right at that point. So this tells me that if I try my new rule, which is averaging those two endpoints, we should end up at the point 1, 1/2. So let's check it out. So the x's are -2 and 4. Divide that by 2. Y's are 2 and -1. Divide that by 2. And so check it out. We have 2 over 2 and 1 over 2. And that's just going to simplify to 1, 1/2, just like we thought. Okay, we have 2 more examples. So let's check this one out by counting. We can go up 1, 2, 3, then to the right 3, 4, 5, 6, 7. So half of the vertical distance would be 1.5. And half of this horizontal distance would be 3.5. And so where we meet up is right there at the midpoint. Alright, now when you're doing halves, it's a little bit tricky to be precise on the graph, so let's use the midpoint formula to confirm what we think we know to be the midpoint. So the two endpoints are -3, -2, and 4, 1. So add up those x's, -3 plus 4 divided by 2. Add up those y's, -2 plus 1 divided by 2. And notice that we end up with 1/2, comma, -1/2. So 1/2 would be here, -1/2 here, and that's our point. Okay, last one. Let's just do it with the midpoint formula. This endpoint to the left has coordinates -4, +6, and to the right we're at 8, 1. So checking it out in the midpoint formula, -4 plus 8 divided by 2, 6 plus 1 divided by 2. So it's going to give us 4 over 2, comma, 7 over 2. 4 divided by 2 is 2, 7 divided by 2 is 3.5. So our midpoint should be at the point 2, comma, 3.5, right there. Okay, so let's just make a note of the midpoint formula. It's the average of the two x's, so x1 plus x2 divided by 2, y1 plus y2 divided by 2. Okay, so now that we know the midpoint formula, we don't really need to have a graph, but we do have a picture here. Keep in mind that these 2 points, these 2 coordinates are x values and y values. Here's an x, here's a y. So plug them into our midpoint formula. We'll take 20 for this first x, plus 4, then divide it by 2. Then take the y's, 31 plus 15, and divide by 2. In this case, we wouldn't really want to graph it on graph paper and have to do it by counting. So 20 plus 4 is 24 over 2. 31 plus 15 is 46 divided by 2. Take and divide. We end up with the point 12, 23. Okay, with our next 3 examples, we're going to jump right in with the midpoint formula. So remember, it's x1 plus x2 divided by 2, y1 plus y2 divided by 2. Again, think of it as the average of your 2 endpoints. So we got an x and a y, x and a y. It doesn't matter which one you think of as x1 and which one you think of as x2. So take -2 plus 6 divided by 2. There's the x's. Now with the y's, take 4 plus -5 and divide by 2. -2 plus 6 is going to give us 4 over 2. 4 plus a -5 is -1 over 2. So 4 divided by 2 is 2, and -1/2. Okay, on to number 9 in part A. I'm going to jump right in. We just have x1, y1, x2, y2. And we'll plug them into that midpoint formula. So 5 plus 8 divided by 2, 13 plus 21 divided by 2. So 5 and 8 is going to give us 13 over 2. 13 and 21 gives us 34 divided by 2. Okay, so 13 divided by 2 is 6.5. 34 divided by 2 is 17. Okay, one last one of this type. I'm going to take -7 plus 4 divided by 2, 16 plus 5 divided by 2. So -7 plus 4 is -3 over 2. 16 plus 5 is 21 divided by 2. Now technically you could leave your answers like that, but it's also okay to have them written as decimals. So -3 divided by 2 is -1.5. 21 divided by 2, 10.5. Okay, number 10, we have a little bit of a challenge here. So we have this line segment, AB. And you know I like to have visuals. And it has a midpoint. And I'm just going to call that M for midpoint. And we're told that AB has a midpoint at 2, 4. And point A has coordinates 1, negative 2. And we want to find the coordinates of point B. Alright, you could do it the algebraic way. You could take this endpoint here and average it with this endpoint and set it equal to the midpoint. And here's what that would look like. X plus 1 divided by 2. Y plus a negative 2 divided by 2 is all equal to the point 2, 4. So that means that this portion is equal to 2 and this portion is equal to 4. So you can write that as an equation. You can say x plus 1 over 2 equals 2. And I'm going to say y minus 2 over 2 equals 4. Because adding a negative, it's a little bit cumbersome. So when we're adding a negative, it's the same as just doing subtraction. Right, if it helps, put the 2 over 1 and the 4 over 1. And what you have here is a proportion. So you can cross multiply. So we'll take 2 times 2, and that's 4. And take x plus 1 times 1, and you get x plus 1. When you solve that little equation, you get x equals 3. Okay, cross multiply. 2 times 4 is 8. Y minus 2 times 1 is y minus 2. Take and add 2. You get y is equal to 10. So that means that our other endpoint has coordinates 3, 10. And you can check this out by finding the average of your two endpoints. 3 plus 1 is 4, divided by 2 is 2. 10 plus a negative 2 is 10 minus 2, which is 8, divided by 2 is 4. Okay, but I have to let you in on a little secret. There's actually a shortcut. Because we know the midpoint is the same distance from the two endpoints, you're going to have the same change in x from 1 to 2 as we have from 2 to the other endpoint. And notice that from 1 to 2, we're adding 1. So if you continue with that, 2 plus 1 gives you 3. Follows the same pattern with the y's, same distance away. Negative 2 going to positive 4, you're adding 6. And 4 plus 6 is how we arrive at 10. Right, so you can do the algebra if you choose to, or you can follow the pattern. Choose whichever method makes more sense to you. Okay, so when we find a midpoint, we're dividing a segment into just two equal parts. So the two parts have a 1-to-1 ratio. Each part has the same length. In number 11 and the rest of the problems, we're going to be dividing the line segments into sections, into more sections than just two. So number 11, it says locate point C on line segment AB that partitions the segment, that means cuts it up, so that the ratio of AC to CB is 3 to 2. So we want to have 3 pieces, 3 sections that compare to 2 sections. So we're going to put point C somewhere on this line segment so that it'll do just that. It'll divide it into 2 lengths so that one part of it has a length of 3 and the other part has a length of 2. Okay, so here's an idea. We want to count, like follow a pattern going from point A to point B. And by the way, this is a directed line segment, so we want to compare AC to CB. AC is going to be the longer segment. Alright, so if we take a look at point A, to get into my pattern, notice that I can go up 1 and to the right 2, up 1 to the right 2, up 1 to the right 2. And if you notice, I've done that for a total of 1, 2, 3, 4, 5 times. The total of these two numbers, 3 plus 2, is 5, representing our 5 segments. Okay, so when we decide where to put point C has to divide the segment this segment AB into two segments, 3 to 2. Now these 3 pieces and these 2 pieces are all equal to each other. So we want to compare 3 to 2. Our point C is going to go right there. And it has coordinates 8, 6. Again, it divides it into a ratio of 3 parts to 2 parts. So what you want to do is find that total first of those 2 portions of your ratio, and then divide your segment into that many parts. Okay, number 12, it says locate point F on DE that partitions the segment so that the ratio of DF to FE is 1 to 3. So we're going to have a little segment compared to a longer segment. So keep in mind that we need 4 segments in total. Okay, so if we want to try to find a pattern here, it can go up 1, 2, and to the left 3, up 2, to the left 3, up 2, left 3, up 2, to the left 3. Okay, notice that that creates 4 steps, or 4 congruent segments here. Okay, if we're going to divide the segment into a ratio of 1 part to 3 parts, we have to go DF corresponds to the 1 part, FE is the longer segment. We're going to put point F right here. So DF is here, with point F being at 7, 1. And notice that DF has a length of 1, if you will. And then FE would have a length of 1, 2, 3. And that's it. Okay, this last question is a little bit different. It says point G at 7, 6. Oops. Point G at 7, 6. Let's try that again. 5, 6, 7. Point G at 7, 6 partitions line segment FE in the ratio of 4 to 5. Okay, so we need 9 segments total. Find the coordinates of the endpoint F if the coordinates of E are 3, 2. So 1, 2, 3, 1, 2. Here's E. Okay, so notice that going from E to G, we can do this a couple different ways. Okay, we can go up 1, right 1. So notice that was 1 step, 2, 3, 4. There's the 4. Okay, now if we want to find point F, we're going to continue on with this pattern, and we want to go 5 segments. So 1, 2, 3, 4, 5. And then our other endpoint at F will be at 12, 11. And we can connect it with a nice line segment. Clean up the ends because it wouldn't have to have a definite endpoints to it in this case. Okay, so again, the process here was we started by plotting point G at 7, 6. We then plotted point E, 3, 2. The question is, we have to find the other endpoint F, so that G is partitioning line segment FE in the ratio of 4 to 5. This segment from E to G was 1, 2, 3, 4 units long. So that's how I knew my remaining segment had to be 1, 2, 3, 4, 5 units long. Continuing that pattern to find our other endpoint. All right, good luck on homework number 4. As always, make sure you speak up and ask me questions or see me for extra help if you're having difficulty.